we are going to go ahead and get started. We're at the top of the hour, so thank you everyone so much for joining us for our Detect to Protect webinar today. We really appreciate that you are taking some time out of your schedule to join us. My name is Kim. I'm from Stamus, and I'll be hosting today's webinar and managing questions during the Q&A session, which will take place at the end of the presentation. Today, joining us and hosting and presenting will be Phil Owens. He's our VP of Customer Support at Stamus. Mark Durret, our CMO, is also joining us, and he's going to give you a brief introduction to the company before we get started. During the webinar, we're going to be launching a few poll questions more towards the beginning, so please listen for those, and we'd love to have you participate in them when they appear on your screen. I also wanted to give everyone just a quick reminder that the webinar is being recorded, and a link to the recording along with the slides and some additional materials will be emailed out to everyone early next week. If you do have questions during the presentation, we'd love to have you enter them into the Q&A window, and then we'll address them at the conclusion of the webinar. So let's go ahead and Phil, if you just want to move to the next slide there, the agenda. This is just a quick look at what we're going to be covering today. As I mentioned, Mark's going to give us a quick introduction to Stamus, and then Phil's going to take us through a presentation materials and also show you a demonstration of the product. And then we'll close just giving you some additional resources, and we'll move on to that Q&A session. So with that, I'm going to go ahead and turn things over to Mark.
Okay, well, thank you, Kim. So before Phil gets started, allow me to share a brief introduction to Stamus. Stamus was founded 10 years ago in Paris with a single conviction, really, that the network layer was the SOC's most undervalued asset. And Clear NDR is the platform we built really around this belief. These four pillars here reflect why security teams in financial services, government, and critical infrastructure have chosen Stamus networks. Really, it's around these four things: structured ground truth for AI and SIEM platforms, detection logic that you can audit from end to end, flexible deployment for data sovereignty requirements, and conclusions, real incidents, not just alerts, named threats with complete evidence, completely ready for investigation. So we've been proving this approach in NATO's largest cybersecurity exercises for 10 years. We've been recognized by Gartner, IDC, Omdia, Frost & Sullivan, GigaOM, and others. And today's conversation is really about what it means for threat hunters in the room, what AI genuinely changes, and what it still can't really do without the right intelligence feeding into it. So with that, I'd like to hand it back over to my colleague, Phil Owens. Phil?
Thanks, Mark. Thank you very much. So as was said, I am Phil Owens. I am the VP of Customer Solutions here at Stamus Networks. I do own the support organization, so just keeping that going. The other thing that I wanted to point out, I've been in the industry for a long time now. Just real quick about me, right? I've been doing network security here at Stamus for over 5 years, and then prior to that, I've worked at RSA, IBM, AT&T, other organizations doing network security. So that's really where my background lies. AI became a really cool hobby for me as well. So putting these two together was pretty nice from a presentation perspective. So with that, we'll just dive right into the actual presentation and get going. Really, Kim, are we going to set up the poll questions now? That would probably be good.
Yeah, whenever you would like.
Bring them on.
All right. All right, so we have 3 questions. So the first one is, are you currently using AI in your security tool stack? So hopefully everybody can see those. Phil and Mark, those are visible for you?
I see them, yes.
Okay, great. So if you answered yes, is it because individual tools have AI embedded in them? So that's just a yes or no. And then finally, we have, are you using or planning to use a cloud-provided frontier LLM such as Claude, ChatGPT, et cetera, or a locally hosted LLM in your security practice? So we'll give everybody a few minutes We'd love to have everyone who's on answer these if you can. That would be great. I see some coming in. They're slowly trickling in. All right, we'll give it just about 30 more seconds. If anybody else wants to participate, you can just scroll to see all those questions.
Part of the reason for the questions here right up front is just in case we have some stragglers that are coming in late. We're not actually starting the presentation just yet. So.
Awesome. We have some more. Thank you very much for participating.
All right, Kim, can we see the results?
Sounds good. We can.
There we go. So interesting. We have 64% saying no, they don't currently have anything in play. If they answered yes, another over 60% says no, they don't have it for individuals. And finally, a very high number are planning on using or are using locally hosted or frontier models in their security practice. So that's actually much higher than I expected. Some of the other places where I've done this presentation, that number was much lower. So this is really cool from my perspective, because this is really what we're going to be talking about mostly. So thanks for participating. I appreciate that. And we can move on. So getting started here, the promise of AI-powered SOC, right? Every vendor was adding AI-powered features. Autonomous threat detection and response was what they were promising, being able to reduce the analyst workload. And what we ended up seeing is that the AI tools,
we're not seeing your screen.
Really? It shows that it did move. Oh.
Yeah,
maybe we have it.
What's that?
You can.
Mm-hmm. The AI security promise versus reality.
Oh, okay. All right. Sorry. Maybe it's just me.
All righty. So sorry about that. Little glitch. So anyway, AI tools generating more alerts, not fewer. We still have AI generated noise, just like we have, an overabundance of alerts as analysts, right? But these are coming in AI generated, so a lot of times you're unsure of what the actual piece was underneath, especially if they came from every vendor. But the fundamental questions are we getting smarter or just noisier? So making the next step over, one of the missing ingredients is context, and we're going to talk about the model context protocol here in a little bit. But what the real key is a lot of times when you're buying all of these solutions for your security stack, they all come with their own AI portions within, whether that's machine learning or AI or however they decide to call them. But what ends up happening is they're running against their own data. So endpoint telemetry, endpoint knows about endpoint, but not about network. And network knows about identity, or knows about network, but not identity, right? Identity would know about identity, right? And cloud about cloud AI. So AI without context is just pattern matching, right? And with that, what's happening with regards to all of this is just the fact that without all the context, it's really hard to come up with the answer at the end. So really what that means is garbage in, garbage out. If you have partial data and you're putting that into an AI, what's coming out the other side of it is going to be not everything, right? So you'll be getting part of the picture. So just a quick jump into the network side of things. Some interesting stats that we've compiled here, actually with the help of Mark. 52% of the MITRE ATT&CK enterprise techniques, right, are network addressable. So you can see those, get those from the network itself. Others are endpoint or identity, but and logs, but 52% of them can be seen on the network. 70% or more, actually, of breaches involve lateral movement, and a lot of these are you don't see them from an endpoint perspective. I know a lot of folks like to get their endpoint in place, but from a lateral movement side of things, the endpoint itself monitors the PC, the device that it's running on, and may have a little bit of information about IP addresses that it's communicating with and those types of things, but not the actual lateral movement itself, where the network can pick those pieces up. And less than 50% of enterprise assets can even run endpoint agents. I actually, when I saw this stat, thought that was a bit high, but more I think about it, when you're talking about devices that just you can't install the endpoint agent on, that's really a blind spot unless you have some type of network intelligence in place. Also, finally, the bullet there, routers alone account for roughly a third of the most critical vulnerabilities. And we've been seeing this in the news pretty often over the last few months, where different devices, endpoint devices, or edge devices are getting attacked from the adversaries. So endpoint has blind spots, right, in critical attack phases and massive coverage gap for enterprises. What we're seeing here is, or the theme here is, we believe that endpoint is absolutely needed and required on a network, but it doesn't catch everything. And really, there's a bigger gap than most people realize without network intelligence in play. So these are some of those items that we were just kind of talking about. Bring your own device, Internet of Things, right? IoT, OT, as well as those network edge devices that we mentioned, and regulated devices, sometimes medical devices that you can't put pieces on. So if you're in that industry, or any other industry that might have regulated devices where you're not able to deploy. Also cloud workloads, and this one's kind of interesting. You can actually deploy a network intelligence device or inside an infrastructure in the cloud to be able to detect network traffic there as well. So the next place that I'm going to go is into the model context protocol. I probably should have had a poll question here. Wish I would have. Now that I'm thinking about it, that said, are you familiar with the model context protocol? Is there a hand raise button on Zoom there?
There is.
Kim?
Yes, there is.
So if you guys could, I'm looking at the participant screen. If you guys could actually raise your hand if you've heard of model context protocol or even know what it is, that would be very cool to know. Excellent. Thank you, everyone, for participating. I do see that there's a few here that actually say they do, so that's great. Basically, the model context protocol, was created by Anthropic, right? The makers of Claude. It's open source, and it has been picked up by basically all frontier models, right, for tool calling. So it's an open protocol. I kind of think of this as a USB-C port for AI or LLMs. And it really allows, instead of having to know every individual API call to get the data that you want from a solution within your security stack, you use a model context protocol, which kind of obfuscates that in back or raises that up a little bit, and the LLM will know what to call and how to get to it. We currently have a model context protocol in server in our environment, and I'll show you that picture shortly. But really what this does is gives a generic API. It's totally plug and play. And like I said, all the frontier models, including most of your local models now, can utilize these with regards to tool calling, as they call it. So you make a natural language conversation. It goes into the agent that you're using. The agent will actually tell the LLM, this is all of the information from an MCP that you have available. So take my question and all of this piece of information, all of this context, and determine, do you need to call the NDR or the endpoint or the identity solution, and make your requests, get that information back, and then put it all together in a final report or final piece of information. So we'll take a look at how that works here in just a minute. So why that it matters is, as you can see, as multiple security systems play out, if you have a model context protocol for each one, instead of having to move across them when you're doing your investigation or your threat hunting, you can actually query this information from the LLM, and it would actually go out, do those queries, and pull that stuff back all correlated for you, so that you have the data available quicker and in one location, and not having to move between tools. One other thing to keep in mind, I know that not all vendors have a model context protocol server, so this is assuming that they might. But the nice thing about it is it's all open source. A lot of folks have actually written their own for their tools, so it's not that difficult. It's basically the description of what it is that the solution is doing, as well as tool names, and then the API calls behind it. Pretty simple type of environment, and you just cook that together, and you could have your own model context protocol server for any solution that's available, as long as it has a API that can be called. All right, so for security, we've kind of gone through this a little bit, but here is an example, right? Are there any lateral movement threats in my network? It goes down, utilizes the agent. What I'm going to show you is agent 0 when I show you the demo portion, and it's going to say, hey, here's the model context protocol that's available to you. In my case, Gemini. And bring back all the information that you can find. And so it makes that call to the MCP server, and you can see some of the individual tools that we have in our MCP server. So we have something known as declarations of compromises, which is also threats on assets. So you'll see there we have threat info, threat families, some host insights information, which gives almost EDR type of data around each individual host within the network, and it can pull that data back. All this data is coming back to the LLM structured, which makes it much easier for it to be able to handle the data and send it back to you without hallucinating a lot of the data. So just because it's structured, it makes it much easier for it to move forward. So the network intelligence logs with the MCP, we're doing AI direct queries. Right, and they can be conversational like this. As you will see later, they can also be more like a skill, or even agentic. So we'll talk a little bit about that as we move forward. All right, so why is it revolutionary? Any security tool can implement it. You can even implement it for a security tool. So that's there's no vendor lock-in. And it allows you to bring your own AI approach. So as the question was asking, we didn't dive into how many of you might be looking to use a local LLM versus one of the frontier models. But all of them even at the smaller local models, which I play with on a pretty regular basis, can make these tool calls and utilize these MCPs to be able to uh, deliver data back. And really what this is doing is you take the intelligence of the brain that is the LLM and add to it the ability to get external data that you wouldn't normally be able to see with an LLM in a chat session anyway. So just really the whole idea of something standard that allows for this to take place. Here's some examples of this, right? So we talked a little bit about lateral movement. It doesn't have to be queried just like this. I actually queried it this way due to the fact that in my demo environment, I had a tenant involved. So we are multi-tenant with the solution. So that's why you see tenant 671 here. But really the key here is show me any unusual lateral movement in the past 24 hours. And we can see what's happening behind the scenes. And I get a really nice report back of what it is that is happening. I will tell you that in our newest release, one of the really cool features is if there are threats involved with any of these queries, it can actually return a URL so that you can deep dive back into the ClearNDR console and do your investigation like you might normally. You can keep drilling within the LLM as well. So behind the scenes, it's querying network flow data, it's correlating baseline behavior, identifying anomalies, and returning a contextualized answer. So that's what you're seeing here. So natural language to network intelligence. The building blocks and what you need. We've kind of seen this diagram already, but the deal here is that you need a network visibility platform from our perspective, or any of the solutions that you might have in your security stack. An MCP server implementation, it could be custom, like I was mentioning before, or it could be vendor provided. What I have noticed is, for instance, I haven't seen that Microsoft has an MCP for Active Directory, but I have seen there are open source MCP servers available for Active Directory. And you could find one of those, put that in place, and then start to query the Active Directory information as well, alongside of the network pieces, alongside of the EDR. All of that can take place. You need access to a large language model in order for this to work. Again, this is Claude, ChatGPT, Gemini, or an internal LLM. Some of you in Europe might be going with Mistral, for instance. So all of them can work. You'll need a client software that can support the support the MCP server as well, because it actually is what sends the data off to the LLM along with your prompt. And that could be an agentic client, or it can be, in my case, Agent Zero or Open Web UI, whatever you've decided to standardize upon. I know that Azure's and I believe ChatGPT's clients can actually support MCPs as well. And the bottom line is, it's going to work with your existing security stack. So not just anything new, right? You could go out and get one of those custom created, or create your own MCP for these things. All right, so real quick, from a threat hunting framework perspective, if we start in the upper left, right, you'll start with a human hypothesis, just like we always have from a threat hunting perspective. Still, irreplaceable. You can actually put your hypothesis into an LLM and help it refine it, which is often pretty nice, as well as helping you generate the prompts needed from the hypothesis that you've come up with. You do the AI-assisted data exploration, where the MCP helps, and the network evidence validation, right? The ground truth. So all of the data. One of the things that we like to say from a network perspective, especially from an NDR side of things, is On a network, when an adversary comes in, some of the things that it's going to be looking for, they're going to be looking for is, do you have a endpoint solution? What endpoint solution? Is there a way that I can turn it off? And they can see all of that as they're moving through, whereas a network detection response is typically passive on the side of the network. And with that, they don't even know it's there. So they don't even know what to turn off. So that's why we say that network evidence provides the ground truth on things. And then iterative refinement. So between you and the AI collaboration, just refining that hypothesis and going back through. Finally, creating an automated prompt for agent or scheduled execution, which we'll talk about. So it could be agentic, so you could turn it into an agentic or automated skill that would be utilized. And then the ability to create multiple agents, each with specific tasks, orchestrated by a master agent. Some of the things that are pretty interesting. Those of you on the call, I've been playing with OpenClaw. I'm sure most of you have probably heard of that, just because it's been in the news an awful lot lately when it exploded over the last few months. And all of its variants out there, Hermes Agent and Nemo Claw and all of those things as well. So turning things into multiple agents where you could have really network specialists, building network specialists on your team to help you go through all of these iterative tasks. So I'm going to show you here some screenshots, but then I'm going to flip over into my Agent Zero client and show you kind of how everything plays together from an MCP perspective and those types of things. So here, are there any strange PowerShell executions, right? Correlate. The AI is going to correlate the process behavior with the network destinations and really just bring down a lot of different pieces of information with regards to PowerShell usage on the network. And really, in this case, strange or unusual PowerShell items on the network. So maybe they're using base 64 encoding of the PowerShell script, those types of things. I'm not sure how many of you use that on your day-to-day basis, running PowerShell scripts across the network. But typically that base 64 stuff is a method of obfuscation. So it would be looking for those types of things and pulling back some of these suspicious activity. So multi-layered correlation, it's able to go through multi-parts of, but not just the NDR, but if you also have an EDR connected here, it can pull that information as well to give you some more details around the assets that are involved and what processes are doing these communications. In this case, we're talking about PowerShell, but the adversary may have changed the name and called it something else. So just keeping that in mind, because they're using a lot of times legitimate tools in order to move around the network. Quick supply chain, right? Are there outliers? We have an idea of things that are anomalies. Most security solutions do, and that's what this is looking for. Any anomalous type of activity, which could, validate suspicious software behavior quickly. This might be something that's time consuming, but for the LLM and the MCP servers, it's something that comes back pretty quickly. Just understanding what's communicating with what and the current workflows and those things. So key takeaways from the hunting pattern: what works? Network data provides the ground truth that endpoint can't. And again, we're not here. It sounds like we're dishing on an endpoint, but we're not. The bottom line is both are required in order to have a full understanding of what's going on and being able to get all the forensic evidence that you might need from an auditing perspective, or if a breach were to occur and you need to you need to put that information out, then you have all the information that you need. The AI accelerates correlation just much faster than humans can, but we're not looking to get rid of humans. We want to make this much more efficient so that you can work on the fun stuff and not have to do the mundane pieces, right? And the techniques are tool agnostic because the MCP server pieces are very open and easily implemented. So what can you do Monday? Start documenting baseline network behaviors, identify which hunting queries take you hours, and evaluate whether your network data is AI accessible. So that's one piece to keep in mind from a privacy perspective, obviously, is making sure that you're okay with where you're putting that network data, as well as endpoint data. Any of your security tools, you need to make sure you have that in a secure tenant of one of the frontier models, or in certain instances doing these local LLMs. All right, so from a demonstration perspective, I have a few slides with actual screenshots. They're very hard to read, so I'm going to go over to my client and show you what those might look like. And then finally, I'll wrap it up with some stuff that I'm doing on my home network that you might find kind of interesting or fun, or something that you might be interested in doing on your own. So with that, I'm going to move over here to, I'm using Agent Zero as my client software to be able to communicate with. In this case, I'm communicating with Gemini, utilizing an access token or key, and sending it a prompt. In this case, a prompt. So what we saw in the slides was a conversational communication with the AI, which is how I first started when we were playing with the MCP, and then came to the realization that maybe I can do better or do something more interesting. So in this case, I formulated a slide with the help of AI. I won't lie. I formulated a prompt, if you will, engineered it so that it has a standard operating procedure for doing some hunting on the network. And while it's a static prompt, it does go out to the internet to look for the latest and greatest threat intelligence, right? Today's active exploits, CVEs, and things like that will actually pull back. And then it will look for those on the network. So while, again, it's a static prompt, it does change in how it's actually, or what it's actually looking for on the network, along with any threats that might have been found by ClearNDR. So that's what you see here. So standard operating procedures. I'm not going to walk through all of this, maybe just point out a couple pieces. You'll notice that I do use the tool name inside of here, which is some folks might think that that's cheating, but really you're going to know what those tool names are. So there's no sense in not telling it, hey, use this tool and use this tool, just to kind of cut down on any potential hallucination. And I find that when you're more direct, you obviously get back exactly what you're looking for, with very little, if any, hallucination at all. So you got step one, or the standard operating procedures, then the active investigation, right? Don't investigate every single alert, pretty inefficient. Grab the top 5 and then give me some information about them. Get the IP details. So this is that host's information that we were talking about a little earlier. So getting details around what services and everything. One of the ones that was interesting is, do not write recommended action is for you to investigate this IP address. Go ahead, you're the investigator. Go ahead and investigate it, and then give me the results. And that made a huge difference, actually, in some of the outputs as I was iterating through this prompt. Then at the end, what it's basically doing is creating me a markdown report. Tables containing data found and enrichment details all around what was found in the triage and the active investigation, as well as the standard operating procedures. And then a little bit with some zero tolerance, basically only report the data returned by the tools, don't hallucinate. Also, don't suggest next steps that you could do yourself, which I'm just kind of reinforcing up above. And Agent Zero has a tendency to keep some memories that are not. So this last one is really around this particular client. I remove this when I'm not using this client. So this prompt we would be more than happy to share with you if you'd like. But what I want to do next here is you're seeing the prompt, what's happening behind the scenes. And this is why I'm using Agent Zero, because it's very good at showing those pieces. So as I scroll down, you'll see after I hit enter, it goes, it said it's searching memories, but it turns out at the end, it doesn't pull any back. So thank you for that. It does say it's doing it though, because that's part of what Agent Zero likes to do. And then going into searching for methodologies and active exploits. So if I scroll down here, you can see I'm getting the current time. I'm searching Stamus networks for hunting strategies, and then searching for today's exploits. So those are the generation pieces. And in the use side with the search engine, you can see what was pulled back. So in this case, approaching threat hunting. The reason I did this is because we've written a lot of collateral around threat hunting with an NDR. So utilizing our blog as well as our docs to help guide the LLM in which way to go about the hunting procedures. So you can see the different things that were pulled up from that perspective. I'm not going to go through every step here. There are a lot of them, but I thought that some of the interesting pieces here are the one right here, I believe, with this search engine, where you can see it goes out to CISA, it goes out to different web pages to find the active threats of the time that this particular prompt was run. So going out there and getting these pieces of information, looking at the CVEs, understanding what the IOCs are associated with it, so that it can actually search for those within the network. All right, so you can see it's doing all kinds of things, including the tools that we were talking about before. So the get IP details, the alert list, the threat list, all of that. So it runs through all of these scenarios and then comes back with a threat hunting report and critical security incidents detected. Now, this is on a demo environment. Hopefully it comes back with nothing. But as you can see, in this case, there were lots of things going on in this particular network. But what you'll also notice is the information being pulled back for each one gives me an idea of who patient zero may be. If they're domain controllers or end user PCs, different Windows 7 legacy machine that's out there that's vulnerable, phishing victim. So we can see all of the different things that are happening. Now, hopefully, again, your report doesn't look like this. This is some demo data, and it would be kind of boring if it was just, hey, all clear, everything's fine. Don't look here. So then the next thing that the LLM can help you with is the recommended next steps, right? So in this case, isolating that particular machine immediately, right? It's a confirmed beachhead, so my patient 0 and C2 beacons, and then isolate 110 and 155 from further credential theft or payload, but do not isolate my domain controllers, because I might take down my whole network, but get into them and figure out what's going on. If you have multiple domain controllers and you can isolate the ones that are impacted, that would be great if everything fails over. But just in case you can't, it's basically telling you go in and take a look at what's going on. And then some remediation and recovery. And finally, some forensic analysis, get some forensic analysis, capture the PCAPs, go in and download the PCAPs and those types of things. The LLM doesn't do that for us automatically. So just to give you an idea. So going back to this, I run that prompt as a task over here. on a daily basis, and it gives me my report. So I could set this up to run within Agent Zero every day at 8 a.m. So when I come in for my morning coffee, I have a report ready for me with information on what might have been found, what's going on my network. So that is one of the cool plays that you can do with this. The other thing that I wanted to show you that happened to me just last week, and this is the same stuff, I'm going to scroll through there, is this. So I've taken that prompt and utilizing open code and created myself 5 or 6 agents. One that goes out and looks for my threat intelligence, one that goes out and is actually doing threat hunting, one that actually writes Suricata rules and IOCs and gives me the IP addresses and everything for the new threats that are found by my threat gatherer or the agent that's going out to the internet gathering information, bringing back IOCs and things, so that I have another agent to kind of separate and stay a little bit more secure with regards to prompt injection and those types of things. Because if I'm looking at the internet, that could cause me some havoc. But if I'm pulling that in and then structuring the data, then the data being delivered to the one that can actually write my IOCs and my rules, it's actually getting structured data, which hopefully alleviates some of that prompt injection situation. But this happened to me. You can see the time there. I'm in Eastern time, so I believe it was around 5:30 at night or in the evening on Wednesday last week. And basically my Sentinel, which runs every 15 minutes, came back and said, "Hey, I saw this happen on your network." And it sent this to me via Telegram. It could have sent it via Slack or Mattermost or Teams, whatever you might be using, and alerted me to the fact that I needed to take a look. Now, I'm not using an F5 big IP, right, or anything like that, but I did see this exact piece of information and was able to verify that this was real. So basically, it was telling me I was being attacked, which I was. Just turns out that it wasn't bad. So just keeping that in mind, and these things are just running on a regular basis and keeping me up to date and alerting me on data. So that's all I have from a presentation perspective. We can take some Q&A if there is any, and move on from there.
Thank you, Phil.
I'll leave it here for some of the resources that we have, right? Our resource library and our blog.
Yeah, you want to go through that first, Mark, before we get on? That'll give people a little bit of time to ask some questions.
Yeah, I just wanted to highlight the fact that Stamus does provide extensive library resources to help security teams build effective AI-powered threat hunting workflows. So we've got a resource library with dozens and dozens of white papers and technical briefs, videos, and we have a blog with well over 200 articles on various security topics, network security topics. So you can check these out and hopefully help accelerate your programs. So that's really it.
Yeah, and if you remember my prompt back there, I am actually searching our blog for threat hunting methodologies because we have lots of them inside that blog post or inside our blog. Lots of different posts about that. I don't know if you saw how many came back, but there was probably about 15 or 20 that came back on this search. So.
Excellent. And we'll include links to these things in the follow-up email as well.
Excellent.
All right. So I do have a couple of questions for you, Phil.
All right.
The first one, how does MCP handle authentication and data security, especially for organizations with strict data residency requirements?
Yeah, so that's one of the key benefits to utilizing an MCP and not just going direct to API with an LLM. is the fact that the MCP can be set up to use OAuth or tokenization or some role-based access control with data. The other really nice thing is that vendors will typically, if they're building the MCP, they're going to build it as secure as possible, as well as read-only. So things can't be changed utilizing the MCP. So just keeping that in mind, especially if you're going to build your own, that's probably some things to understand that you'll want to add to your MCP. So being able to utilize role-based access control to keep access to the data to the people who are allowed to see it, or the agents in this case who are allowed to see it. So.
Okay, great. Next question is, what testing methodology did you use for the demo?
The testing methodology I used was a little bit of trial and error as part of it. But like I said, we started off with creating conversations and what data could we get as we were running through and understanding the data that we were able to deploy or get out of the system with the MCP, and then moving on to where we got to the what we call the mega prompt that was engineered in order to give me that daily report on a regular basis, right? On a daily basis. I get one of those reports, by the way, from my OpenClaw agents. They do the same thing for me on my network every day and deliver me a report in the morning.
Excellent. All right, we have a few more. So the next one is, can MCP work with local or on-prem LLMs, or does it require sending data to a cloud AI provider like Anthropic or OpenAI?
Yeah, so we kind of talked a little bit about that. And interestingly enough, I mentioned that some smaller models and that AI is a hobby of mine right now. And I actually am running if anybody here knows what an AMD Strix Halo is, with 128 gigs of RAM and shared RAM, I should say. And I run a small model, like a Gemma 4 model, with 31 billion parameters on that box, and keep everything local. So all of my data stays local, and it's been running really well just with that small model. So you can do this all internally without having to send to a cloud provider. But the cloud providers do have, obviously, their frontier models. They're going to have the biggest brains, if you will. But the idea is making sure you run through your risk factors and what it is you need to do with regards to any tenants that you're buying from a Google or a Anthropic or an OpenAI, or if you're going to be running a Mistral type of thing from France, for instance.
Excellent. All right, two more. How do you prevent an AI agent querying via MCP from being manipulated through prompt injection? So, for example, if malicious payloads in network traffic influence the query results.
Yeah, so that's a great question, and we're still working through some of those things. I think that's the best way to answer it. Prompt injection is not so much new as it is how do you protect against it. And one of the things that I'd mentioned is that the MCP only has read-only access to what it's doing, and from an agentic perspective, like I'd mentioned, my agents are separated to keep them from being able to do damage when injections might take place. So my rule writer and my that actually has access to machine to be able to do things, that particular agent has no other external connections. It's not connecting to ClearNDR. It's not connecting to the internet. It's getting structured data. It's manipulated structured data from my threat intelligence gatherer in order to be able to do its work. So just as you're building out a potential agentic type of system, keeping those pieces in mind so that you're cutting down on what might be a location where prompt injection could take place. In the mega prompt, I'm going to say that that one's kind of a little bit one of the reasons why I split it into pieces and made it agentic is because of those security concerns as well. So.
Great, thank you. And the last one we have is, at one point in the maturity curve, should a SOC team start experimenting with MCP-based hunting?
Oh, I mean, being honest with you, it should be one of the things that are just part of the foundation of what you're doing now, because of the fact that it's just going to make everyone more efficient as we move further down the road. The tier 1 analyst can become a tier 2 analyst pretty quickly by getting this information. Now the key is to learn from it, not just let it go and do its thing. You have to monitor it and learn by what's coming back from that perspective. So I don't think that there's really a time. I don't think you should wait just because of the efficiency that it gives.
All right, excellent. Well, that is all the questions that we have. Just a reminder to everybody, you could have about 5 more seconds if anybody has anything else, but email will go out early next week to everyone that's been on the call, and we'll include the slides, so the recording link, and also some additional materials. All right, I do not see anything else coming in, so we will go ahead and wrap it up, unless Phil or Mark, you have anything else to add?
Just thank you for joining me and listening to me. Right, I'm just a talking head on here, so I'm appreciative that you took time out of your day to listen to me.
Yeah, thank you very much.
Thank you, everyone.
All right, wonderful. Thanks, and everybody take care.